Well, hello. Today we're going over systems of linear inequalities. So we talked about systems of linear equations, and that was when we had more than one equation. And now we're looking at linear inequalities, which is when we're looking at more than one inequality at the same time. So a system of linear inequalities is a set of two or more linear inequalities in the same variables. Here's an example. A solution to a system of linear equalities is an ordered pair that is a solution to each inequality. So anytime we have an ordered pair, an x value and a y value that make both inequalities true, that's a solution to the system. So the first kind of example we're going to do is testing points, testing ordered pairs to see if they are solutions or not. So here's our first kind of example. So first we're going to test the point 3, 5 to see if it's a solution to this system of inequalities. So remember, it always goes x and then y in an ordered pair. So we are going to plug a 3 in for x and a 5 in for y. So in y is less than 2x, we would be plugging a 5 in for y, and then 2 times the x value, which is 3. And then that says 5 is less than 2 times 3 is 6. 5 is less than 6. So that one checks out. So then we're going to plug the same x and y value into the second inequality and make sure that one works. So then what we're going to do is we're going to take y greater than or equal to x plus 1, and we're going to plug in a 5 for y and a 3 for 1, or a 3 for x. So then we get 5 is greater than or equal to 4, and that is true. So then we can conclude, yes, 3, 5 is a solution. Okay, so that's part A. We're done with part A now. Let's look at part B. Part B is same inequalities, but we're checking to see if -2, 0 is a solution. So we'll take the same inequalities. First, I'll do this one. Y is less than 2x, and I'll be doing a 0 or an x. I'll be switching with -2, and then y will replace with 0. So the y becomes 0, and then this is going to be 2 times the x value, -2. So then this one says 0 is less than -4. Well, that's not true. 0 is actually greater than -4. So this one is false. And that means that we don't even have to check in the other equation because we already know it can't be a solution. If it doesn't work for one of the inequalities, then it doesn't work for the system. So we say no, -2, 0 is not a solution. All right, so to find if it's a solution, you take the ordered pair and you just plug in to both inequalities. And in order to be a solution, it has to be true when you put it into both inequalities. If it's false in either inequality, then it's not a solution. Okay, so that was just testing an ordered pair to see if it's a solution. Now we're going to look at graphing systems of inequalities and then getting a visual idea of what the solutions look like. So when you graph a system of linear equalities, basically all you're going to do is you're going to graph both inequalities on the same coordinate plane. And then each one of them has like a shaded half. And then what you're going to do is, in order to figure out the shaded area is where the solutions are for that inequality. So in order for a point to be a solution to both inequalities, it would have to be in the area where both are shaded. So it's in this overlap shading area. So the solutions to the system of inequalities are all the points in the area that where the shadings overlap. So for this one, it would be just in this purple area. It would include this red line right here because it's solid. So this one would include all these points on this part of the line and all the purple shaded area. It wouldn't count any points on that side of the line because those aren't solutions to both. Or actually, let's see, no. Yeah, three solutions to both because it's in the shaded area. Okay, so in order to graph a system, you just graph both of them and see where the shading overlaps. So let's look at some examples where we do that. No, I have to do the next part. I have to do the next part with the animation, so I need to change my sharing. Hold on a sec. The next ones are animated, so I do have to do this part. Okay, can you guys see that now? Still seeing this? Okay. Okay. A little better this way anyway, apparently. Okay, so we're going to graph this system of linear inequalities. So first we're going to graph this one. Y is less than or equal to 3. So anytime there's only one variable showing up, that's going to be either a horizontal or vertical line. And the way I like to remember is I'll pick, you think about graphing the line y equals 3. And then the trick is you just pick a couple of points that both have a y value of 3. Like, for example, 0, 3, and 3, 3. They both have a y value of 3, so I can use those points to plot my, to figure out where my line is going to go. So 0, 3 is over 0, up 3. And then 3, 3 would be over 3, up 3. So that looks like it's going to be a horizontal line. So I'm going to draw it a solid line because we have the equal to sign. We have the little line under our less than. So that means we do a solid line. And then the less than part says we're going to shade below the line. So there we shaded below the line. Now to graph the second inequality, we want to think about the line y equals x plus 2 and think about what points we're going to have there. So we've got a y-intercept of 2. So that means we get a point over 0, up 2. And our slope is a 1. It's an invisible 1 in front of that x. So slope is 1. So that means we go rise of 1, run of 1. The slope of 1 is 1 over 1. So we go up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. Same thing in the other direction, but opposite. Down 1, left 1, down 1, left 1. Now let's look at our sign. There's no equal to under it, so we need to have our line dashed. And then the greater than part says we're going to shade above our line. Now we need to see, to find the solutions to the system, we need to see where these graphs overlap their shading. And that would be this triangle region right here in purple. that is where the shading overlap, and that represents all the solutions to the system. And it includes, since this part of the line is solid and it's shaded, it includes, so this part of the solid line includes solutions to the system and then all the shaded area. But the dashed red line down here, those would not count as solutions to the system because they're not actually solutions to the red inequality. So then so the solution really is this picture where the purple stuff is. And that represents like all the solutions. And there's infinitely many solutions. Each one is an ordered pair in that area. So this point right here would be a solution. This point right here would be a solution. Any point in the purple area would be a solution. Any point on this part of the red line would be a solution. Anywhere in the purple and anywhere on this part of the red line, but not over here. Okay, example 3. Now this one we need to kind of, in order to graph this, we need to rearrange some things a little bit because we want to have the y by itself. So I'm going to take inequality 1, 2x plus y is less than -1. And I want to get the y by itself. So I am going to subtract 2x from both sides. So 2x minus 2x is 0. So we just have y left on this side. And then these aren't like terms, so we just leave them. So -2x minus 1. Okay, so now we're going to graph this inequality. We've got it in slope-intercept form now. So we know that our y-intercept is -1, and our slope is -2, -2/1. All right, so our y-intercept is -1. So that's right here. And then our slope is -2. So that's down 2 every time we go to the right one. So we can go down 2 to the right 1, down 2, right 1, down 2 to the right 1, and then you get an idea of where that line is going. Okay, now when we draw the line, we need to look at our inequality sign here to determine if we're drawing solid or dashed. Solid is if it has the equal to line under it. This one doesn't, so this one's going to be dashed. And the less than sign, for y to be less than something, that means it's below, so we're going to shade below this line. So that is the first inequality all graphed up. Now let's do the second one. So we're going to take 2x plus y greater than 3. To get the y by itself, we need to subtract 2x. So I'm going to subtract 2x from each side. And we get y is greater than -2x plus 3. So for this inequality, we have a y-intercept of 3 and a slope of -2. So we would start at our y-intercept of 3. And so that would be the point 0, 3. And then our slope is -2. So we would go down 2 to the right 1, down 2, right 1, down 2, right 1. And then we've got, we're going to have to do a dashed line because we don't have the equal to sign underneath here. And we're going to shade above because this is y greater than. Now, the situation we have here is that there is no place where the shadings overlap. So if there's no overlap of the shading, that means no solution. So no solution means there's no overlapping of the shading. There's no point anywhere on this graph that is in both shaded areas, right? So there's no point that's a solution to both inequalities. Okay, and now the last kind of problem we're going to look at is looking at a graph and then writing the system of inequalities that it represents. And the way we're going to do that is there's just 4 things that we look at. We need to find, we're going to look at the dashed or solid, right? Because that'll tell us dashed means that it's going to be either greater than, less than or greater than. Solid means less than or equal to or greater than or equal to. So that tells us whether or not we have the little equal to sign, right? We're going to look whether it's shaded above or below. Shaded above means that it would be greater than or equal to. Shaded below is either less than or less than equal to. And then we need to know the slope and the y-intercept. And that's all we need. Because all we have to fill in, because it's like y, and then there's going to be an inequality sign. And then mx and plus b, right? So we need to know what is m, what is the inequality sign, and what is b. Okay, so let's look at the dashed one here. We've got a y-intercept of 0. Our slope is, let's see, we go up 1 over 1, up 1 over 1, up 1 over 1. That's a rise of 1 for a run of 1. So for this line right here, slope is 1 because it goes up 1 over 1, right? So 1 over 1 is 1. So we know that the slope is 1, the y-intercept is 0, so b is 0. And it's a dashed line, so there's not going to be the equal to part under it, and it's shaded below, so it has to be the less than sign. So when we write this inequality, we do y shaded below and a dashed line, we just do less than, and then mx plus b. M is 1, so we don't have to write the 1 because 1 times x is just x. And then plus 0, you don't have to write the plus 0 because 1 times x plus 0 is just x. So this is the first inequality. Now we need to find the second inequality. So the second inequality is going to come from the solid line down here. So it's solid and it's shaded above. So that means it's going to be y, or it's going to have a greater than or equal to. But since this is a horizontal line, this one's a little bit tricky. Horizontal lines don't have slopes, so they don't actually have a slope intercept form. And if you remember, a horizontal line is format like x equals a number. So a horizontal line in an inequality is going to be x is greater than or equal to something. And what is the x value down here? Right? Every point on this line has an x value of -2. This point right here is 0, -2. Oh no, yeah, this is a y. Never mind. I was being silly. This point is 0, -2. This point right here is 2, -2. So what do those points have in common? Both of them have the y value is -2. So this is going to be, the horizontal line has a slope of 0. So that means that we're going to do y, we're shaded above this thing, so that's greater than. The line is solid, so that means equal to. The slope is 0, so 0 times x is 0, but the y-intercept is -2, so it's just y is greater than or equal to -2. So if the line is slanted, you're going to have to find the slope. If the line is horizontal, the slope is 0. If the line is vertical, then it's going to be an x less than or equal to or greater than or equal to. But this right here is the system of linear equations that we have graphed here. Y is less than x, that's our dashed line shaded below. Y is greater than or equal to -2, that's our horizontal solid line shaded above. Okay, we've got one more example of doing a problem like this. Okay, now here's what we talked about. I was thinking about this last time. We have a vertical line right here, and think about what are some points on this line. I'll do that point and that point. The coordinates of this top point up here, that's 3, 2, 3. So this is 3, 3. This point down here is 3, -3. So with a vertical line, the equation of that is just x equals 3. So this line right here, the equation is x equals 3. So that means that we're going to have, it's a solid line, so we'll keep the equal to part, but we have to decide which side. This is the only case where it's not shaded above or below. Only with a vertical line, we talk about it being shaded to the left or to the right. And then we just have to remember which way is x less than, which way is x greater than. This one is shaded to the left. As we move to the left, the x values get smaller. So we're actually shading where the x values are less than or equal to 3. So one of our equations is x has to be less than or equal to 3. So the vertical line x equals 3 is solid, and then everything shaded to the left. So that the inequality that gives us the vertical solid line and shaded to the left is x values less than or equal to 3. Because on this line and everywhere to the left, that's where all the points have x values less than or equal to 3. Okay, next we have a slanted line, so we need to find the slope and the y-intercept. So here's my y-intercept, 0, -1. So I know that b equals 1. B equals -1. And now the slope. So I need to find another point that's on like one of these intersections of grid lines. So it looks like my slope would be, I go up 2 when I go over 3. So that's a rise of 2 and a run of 3. So my slope is 2/3. So I'm going to do y, and then I am shaded above. So that's greater than. The line is dashed, so I don't put the equal to sign under it. Now I do this mx plus b. Slope is 2/3, so 2/3 x. And b is -1, so -1.